Hari Om. Our next topic in matrix is multiplication of a matrix with a scalar quantity. So let us take an example to understand this. If A is a matrix 3, 4, 2, 1, 0, minus 1, and if we multiply this matrix with suppose 2, that means 2 into A is equal to, so if we are multiplying 2 with this matrix, the 2 will get multiplied to each of its elements. So we will get a matrix 6, 8, 4, 2, 0, minus 2. Similarly, 3A will be, now 3 will be multiplied to all the elements. So 9, 12, 6, 3, 0, minus 3. Similarly, minus A will be, minus 1 will be multiplied to all the elements. So minus 3, minus 4, minus 2, minus 1, 0, 1. Alright. So suppose we have a matrix, a general matrix, something like A is equal to A, B, C, D, E, F, and we multiply the matrix A with a scalar, that is K, we get another matrix KA, KB, KC, KD, KE, and similarly, we can also take a single element common from all the elements of a matrix outside. For example, if we have a matrix 3, 2, 4, 1, 6, 2, and if we take 2 common from all the elements, that is if we have divided 2, so this will become 3 by 2, 1, 2, 1 by 2, 3, 1. Here we have to remember one thing, that even if you are multiplying a scalar or dividing a scalar or taking something common, you have to do from all the elements of that matrix. So till now we have seen how to add two matrices or how to subtract two matrices and how to multiply a matrix with a given number or divide a matrix with a given number. Now let us see how to multiply two matrices. So suppose we have two matrices A and B, then by multiplying both of them we will get another matrix C. But here we have some rules. If A is of order m cross n and B is of order x cross y, then we can multiply A and B if and only if n and x are same. That is, the number of columns of A should be equal to number of rows of B. Then only two matrices can be multiplied. If they are not same, if n and x are not same, multiplication is not defined. So for two matrices to be multiplied, this should be something like n cross p. So number of rows of A and number of columns of B might be different, but number of columns of A and number of rows of B have to be same. If these two are same, then A and B can be multiplied, and on multiplying we will get a matrix C, which will be of the order m cross p. This point is worth remembering. You might get this in 1 mark questions. So two matrices can be multiplied only if the number of columns of first matrix is equal to number of rows of second matrix, and on multiplication we will get another matrix of order m cross p. So suppose we have a matrix 3 cross 2 and we are multiplying it with a matrix 2 cross 5. First you have to check that number of columns of A is equal to number of rows of B. So multiplication is allowed and the result will be of a matrix of order 3 cross 5. Alright, if you keep this in mind, we can proceed further. How to do the matrix multiplication? So let's see an example. Suppose we have a 3 cross 2 matrix, means 3 rows and 2 columns. So suppose 3, 2, 1, 0, minus 1. So we have 3 rows and 2 columns, and let us multiply this with a 2 cross 3 matrix. That is 2 rows and 3 columns. So 2, 4, 0, minus 1, 3. As you can see, the number of columns of the first one is equal to the number of rows of the second one. Hence, we can multiply, and after multiplication, we will get our answer in matrix form of order 3 cross 3. So 3 rows and 3 columns. But before that, first of all, since this is a 3 cross 3 matrix, the element which will be here will be A11, this will be A12, this will be A13, the index of these elements, because this is the element in first row and first column. So 1, 1. This is first row, second column. This is first row, third column, and so on. Similarly, this will be A21, A22, A23, A31, A32, and A3. Now, how to understand this? So, suppose we want to find the A11 element of the resultant matrix. By multiplying these two, we will get the answer something like this. So, we need to find these values. So, A11, concentrate on the first number. The first number denotes that we have to take the first row. So 1 means first row of the first matrix. So 3 into 2 means 3 and 2. And first column, the second number denotes the second matrix. So first column 2 minus 1. We have to multiply 3 2 with 2 minus 1. And what type of multiplication? This is something like a dot product. So 3 into 2 is 6 plus 2 into minus 1 minus 2. Just remind yourself once again what we have done. We have multiplied the first row of this matrix, of the first matrix, with first column of second matrix to get this element. Similarly, how to find A12? 1 means first row of first matrix. 2 means second column of second matrix. So 3 2 with 4 3. So 3 into 4 is 12 plus 2 into 3 is 6. Here first row of the first matrix, third column of the second matrix. So 3 2 with 0 2. So 3 into 0 is 0 plus 2 into 2 is 4. So we have got our first row elements. Similarly A21. So 2 means second row. So second row and first column. So 1 0 2 minus 1. So this gives 1 into 2 is 2. 0 into minus 1 is 0. Similarly, for the element A22, we have to multiply second row with second column. So 1 into 4 is 4. 0 into 3 is 0. Second row, third column. So this will be 0. 1 into 0 is 0. 0 into 2 is 0. Here similarly, third row, first column. So minus 1 into 2 is minus 2. 4 into minus 1 is minus 4. 3 2. Third row, second column. So minus 1 into 4 is minus 4 plus 4 into 3 is 12. Third row, third column. Minus 1 into 0 is 0. 4 into 2 is 8. So this is how we will be getting the elements. Now, by solving this, we will get our matrix multiplication result. So the multiplied matrix is 6 minus 2 is 4, 18, 4, 2, 4, 0, minus 6, 8, 8. So on multiplying these two matrices, we have got the resultant matrix. Here, let us remind once again. For finding the multiplied elements, we take rows from the first matrix and columns from the second matrix, which depends on the index. Suppose this element has the index second row, third column. So we will get this element by multiplying second row. So second row of first matrix and third column of second matrix. So let's see another example regarding this. Suppose we have a matrix This is a 2 cross 3 matrix as there are 2 rows and 3 columns. And suppose we have a matrix like this 4, 3, 2. So this is a 3 cross 1 matrix. 3 rows and 1 column. As you can see, number of columns of first row is equal to number of rows of second. So multiplication is possible. And on multiplying these two, we will get a matrix of order 2 cross 1. That means 2 cross 1 means 2 rows and 1 column. So this element will be A11, this will be A21. 2 cross 1 means 2 rows, 1 column. Now how to get A11? 1 means first row of the first column into first column of the second one. So this will be, so first row, first column. So 2 into 4 is 8, 4 into 3 is 12, 3 into 2 is 6. Similarly A21, 2 means second row and 1 means first column. So minus 1 into 4 is minus 4, 3 into 3, 9, 2 into 2, 4. So our result is 26 and 9. Alright. Now let us come to the next topic, which is somewhat an application of matrix multiplication. So higher powers of a matrix. Now, as you know, for any number, 8 square is 8 into 8. So similarly, suppose A is a matrix, then A square is equal to A into A. A cube is equal to A square into A, and so on. All the exponents properties are satisfied here. But here we have to take one care. So suppose A is a matrix of 3 cross 2 order. Alright. And if we want to find A square, so A square will be A into A. So A is a matrix of 3 cross 2 and this is also a matrix of 3 cross 2. And as we have discussed earlier, is this multiplication allowed? If you see carefully, you will get to know that it is not allowed. Why? The number of columns of A is not equal to number of rows of the second matrix. So 2 and 3 are not same. Hence, we cannot find A square. Alright. So, when can we find A square or the higher powers of a matrix? Only if we have a square matrix. So, if we have a square matrix, then the number of columns of first matrix will be equal to the number of rows of second one, and we can multiply to get a matrix of the same order. So if we multiply A and A, we will get a matrix of order 4 cross 4. So higher powers of a matrix is only applicable for square matrices. Alright. Okay, so let's stop here today. We will continue with our lesson in the next parts.